Hello again. All right, 2 videos in one night. Here we go. You guys got this. All right, so the properties of logarithms is the title for these sets of notes. Just one easy page. Okay, so in the other video, I introduced to you guys what a log is, and like I said, a log is just another way to represent an exponent. It's going to look very complicated at first because you all have never worked with it, but it will get easier to look at and easier to work with. Now, just like with exponents, there's exponent rules, right? We know that x to the a times x to the b is equal to x to the a plus b, right? We know that x to the a all raised to the power of b is equal to x to the a times b. We know that x to the a over x to the b is equal to x to the a minus b. So those are all exponent rules that tell you how to simplify down two terms that have the same base, and you're either multiplying or having a power to a power, or you're dividing the terms. It tells you what to do with the exponent. So just like there's exponent rules, there are also obviously logarithmic, the properties of logs, or just like there's the properties of exponents, there's the properties of logs that teach you or kind of help you simplify down logs to single terms or expand them out into like separate logarithms, all depending on what you need to solve the logarithm. So these are going to be super similar. As you can see, the names of the logs, of the properties of logs, are very similar to the properties of exponents, but they're a little bit different. So just like there's the properties of exponents, there's the properties of logs. That's what I'm trying to say here. And we're going to be talking about those today. So there's going to be 3 main properties that we're going to focus on: the product property, the quotient property, and the power property. We're going to go ahead and start off with product and then make our way down. So what does the product property of logs tell us? It tells us that log base b of m times n is equivalent to log base b of m plus log base b of n. Again, very similar to what we see in the product rule of exponents. When you're multiplying, you add the exponents. When the 2 logs are being multiplied, you can expand them as the sum of the 2 logs. Okay, we're going to do some quick examples on that. And like I said, you use these rules to either condense or to expand. So I'll do about one of each, and then we'll go on to the next one. So how we want to go ahead and condense this logarithm into one single log. Obviously, I have a log here and a log here, and they're being added together. I want to condense this down to just one single log. And then it says simplify down your answers if possible. So I have log base 2 of 7 plus log base 2 of 4. Now, so these 2 logs are being added together. They have the same base. So based off of my product property, what do I do with m and n? Well, I multiply them. So this will be log base 2 of 7 times 4, which is equivalent to log base 2 of 28. And that has now been condensed down to a single log. Easy, yeah? I'll do number 3 just because, probably because of the x, it might look a little confusing. Remember, by the way, in number 2, when you don't see a log, remember it's implied, when you don't see a base, it's implied to be 10. That means it's a common log. So going on to number 3, I have 2 logs. They are being added together. They have the same base. So to condense this down, this will be log base 4 of 2x times 4x squared, which simplifies down to log base 4 of 8x cubed. Got it? That's condensing into a single log. The other thing that you should know how to do is how to expand. Now, what does that mean? That they're going to give it to you in a single. You want to expand it back out to the sum of 2 separate logs. So for these, your answers will vary for some of them, because I'll show you in a second. So like, for example, let's talk about number 4. Number 4, our single log is the log of 6. By the way, whenever you don't have the when you don't have the base, remember the base is implied to be 10. So you wouldn't say the log base 10 of 6. You would just say the log of 6. And that implies that it has that base of 10, that it's the common log. So what I want to go ahead and do is expand this out to the sum of 2 logs. So I'm going to have this as the log plus another log, and you got to think about it. You got to find 2 numbers that multiply out to 6. And this is where your answers will vary, because like I'm thinking, I don't know, 2 and 3, but someone else might think 1 and, wait, why did I put Loy? Sorry. Log of 1 and the log of 6. Do you understand what I'm saying? Like for these expanding ones, your answers will vary. But yeah, either one of these work, because if I were to condense them down, I would get the original, because this 2 logs, same base, being added together. So I multiply the 2 times the 3, which would give me 6. Also here, I would multiply the 1 times the 6 to give me 6. So either one of these works. And just so that you all know, when we're talking about expanding, the answers will vary. So I can do like one more here. Maybe number 6, I have the log base 2 of 5x. I want to go ahead and expand this using the product property. So this will be the log base 2 of what I can think of this as is like 5 plus the log base 2 of x, right? This is a potential answer here. Because the log base 2 of 5 is equal to, the log base 2 of 5 and log base 2 of x, and they're being added together. This would go ahead and tell me to multiply this 5 times this x, which simplifies down to 5x. Okay. So that one is the product property. Let's go ahead and try the quotient property now. By the way, you guys are expected to finish the rest of these and then ask me on Thursday if you have questions. So what is the quotient property? The quotient property tells you this. When you have log base b of m divided by n, the way you would, what this is equivalent to is log base b of m minus log base b of n. So it's equal to taking the 2 logs and subtracting them. So I'll do number 7 and maybe like number 11. So I want to go ahead in number 7, 8, and 9, condense it into a single log and simplify all if possible. 2 logs, same base, being subtracted together. So that means that to represent this as a single log, I would just put log base 3 of 24 divided by 8, and 24 divided by 8 is 3. So my final answer would be log base 3 of 3. My quotient rule tells me to take this and this, my m and my n, and divide them. Okay, I'll do number 11. 11, you're doing the opposite. You are not condensing, you are expanding. Again, for expanding, your answers will vary. I need to find 2 numbers that when I simplify them out, they give me, when I divide them out, they give me 1 over 3. Again, answers will vary. I can go ahead and think about this as like, this is equivalent to, you can multiply them both by like, I don't know, 15, I guess. So like, let's just try 15. So that would be like 1 times 15 is 15, 3 times 15 is 45. So you can think about this as like log base 5 of 15 minus log base 5 of 45, because according to your quotient rule or your quotient property, what you would do since you're subtracting them is you would take both of this 15 over 45 and divide them, and 15 over 45 is equal to 1/3. So those are like one potential answer, but like I said, for expanding, the answers can vary. Okay, hopefully those make sense. Work on the rest of them. Let me know if you have any questions. Let's do the power property now. Last one. All right, so what does the power property of logs tell us? It tells us that if we have log base b of m raised to the n power, this is equivalent to n times log base b of m. So the way that I like to think about the power rule as is me taking this exponent and dropping it down to the front. So log base b of m raised to the power of n is equal to n times log base b of m. So let's work on condensing first into a single log, and then we'll go expanding. So condensing into a single log. Here, they give me a number up in the front of my log base 4 of 2. So this is the opposite. Rather than taking the exponent and dragging it to the front, I'm taking my front number and I'm dragging it up to the exponent. So this will be equivalent to taking this and putting it up here. So it'll be log base 4 of 2 to the 5th. And what is 2 to the 5th power? Well, that is equivalent to log base 4 of 32. So that would be your condensed single logarithm. Let me try an expanding one now for you guys. So, for example, if I have, which one should I do? I can do number... Ooh, let me do number 17 because I feel like that one might throw people off. So for number 17, you are expanding. You are not condensing. I am not taking the 3 and putting it to the exponent. I am expanding, so I am taking this exponent and dropping it in front. However, you have to be careful because in this case, you already have something up in the front. So what you're going to do is you're going to take this and drop it here, but you notice that there's already something there. So this will be 3 times x minus 1 log of 4, and then you just distribute out the 3. So it'll be 3x minus 3 times log of 4. And that is my expanded answer. Alrighty. I think that's it. Hopefully you all don't need me to do any more. But if you do, let me know. Try the rest of them and then ask me on Thursday if you have any questions. Thanks, guys.